Alright, so this experiment is pretty simple. You just need two materials, which are a syringe and a small marshmallow, small enough so it can get into the syringe. So the procedure of this is that you put the marshmallow in the syringe. This one's already in, so I don't need to worry about that. And you need to push or pull the lever of the syringe so it can reduce the volume of the container or expand it. And so my hypothesis for this is that the marshmallow and the volume of the container are proportional, directly proportional. So this means that if you make it smaller, the marshmallow shrinks. If you make it bigger, the marshmallow expands. And so let's perform an experiment with the only thing that you need to be aware that this matters, this just works if you put your finger so you can block the air from coming in or out. So, first of all, it's right in the middle. You need to push. It's hard to see, but the marshmallow is actually getting smaller, like shrinking to the center. And, well, the opposite happens if you start from here and just pull. In this case, the marshmallow gets bigger. I remark it's hard to see, but it actually happens. And so, well, I think my hypothesis was correct. It happened as I expected. It is actually directly proportional to the volume. Like the marshmallow shrinks if the volume shrinks, and the same. And so, what the law that this is related is the Boyle's law. It's pretty simple because, well, in this case, temperature doesn't matter. It's out of the equation. It's constant, and so, well, the law that corresponds to that is Boyle's law. And, well, here I have a small diagram, which is between that represents it. So you have temperature out of the equation, you have just pressure and volume. If the volume gets smaller, the pressure goes up because, there's more density of particles in an area. And so that's the same for here. Like, this is the air pressure. And so the reason why the marshmallow gets smaller, if it gets smaller so it gets more pressure, is because it is receiving more pressure from the air, therefore it has less space to take. And if you have the opposite case, which is pulling, you are actually doing pulling out. So the marshmallow has pulling air out, so the marshmallow has more space to be in. But as it's a vacuum, the air would move, so the marshmallow is just in the way and it will expand. And so I think that was pretty much it. Thanks for watching. Bye bye.